Hi, in this video we're going to talk about the physics global options and some extra dynamics features. They are very important for the physics simulation. Let's first open our example and introduce the first step is inertia. So let's first open the example 36. Still the previous one, the partial and brake dynamics. And let's make our agent more than this number. Select the place node and increase the number of agent like this, and place our agents and play back. Let's make them work faster. The action playback, and change all action playback speed to the 2 and then make them our agents walk faster like this. Okay, and let's just delete the avoidance detection logic here and make them walk straightly, just like this. And let's create a bound. We're going to make our agent enable dynamic inside of this bound. For example, we put the bound at here and create a logic here in bound done. And let's add a logic, the bound, and in bound, and enable dynamics. So you can see that when you play back the simulation, the agent will fall down inside of this bound. So here you can see that there's the icon like the atom. This is kind of the physics global. We're going to introduce something, the options inside of this. The first is the inertia factor. The default value is 0.3. Let's just decrease this down to 0 and see what will happen. This should be deplaced and placed our agents again. You can see that our agent will fall down directly without any of the inertia. And if we just increase and correct this down to 1 and deplace our agent and place that again and playback simulation, you can see that our agent will the fall down forward with the big inertia. So with this option you can tweak how the big inertia factor inside of the scene. Just try to deplace and place your agents again and make that work. So this is the OK value. And then the next thing we're going to talk about is a step time. The step times can simulate the faster or slower the simulation. Please notice that the gravity cannot change this kind of the result. Each step times can control this. Let's decrease that down to 0.1 and see what will happen. You can see that the dynamic can be happened very small, just like something in space. And let's just make that bigger value, 4.5. You can see that the simulation will be very fast, okay, just like this. So you can tweak these values if you think your scene can accelerate or decrease the speed as you wish. And the next thing we're going to talk about is the substep. If your agent is very complex, we can increase the substep to make that in the simulation more accurate. But please keep this value the relatively small, something less than 10, for example 8. It can make the simulation the more accurate and decrease the jitters to something in some case. The 1, for example, and let's see what will happen. Oh, let's click this. You can see that there's a lot of jitter because the simulation accuracy has been decreased. Let's just resume them back to 5. If you increase this value, sometimes the bigger your increased, the slower of the simulation will be. So just to keep this value the relatively down and you can track this by your experience and based on your simulation situations. So you can see that 5 is okay. If you increase the value to 50, it's not going to help. So the result should be similar than 5, just to keep this the small value. And then the next thing we're going to talk about is the how to block the same type collision. So you can see that this is a sample 39 that we previously created, and when we placed our agents and the playback, the simulation, you can see that it can check collide by the head and enable dynamics when the collide happen. So here in the physics global, you can see that there's an option here, the block same type collides. This is going to be very useful if you want to simulate the two groups of different armies collide each other, but you don't want to make collide in the same type of armies. For example, you have the two groups of armies, the blue and the red. You want the blue and the red collide and enable dynamics that make something very big thing, but you don't want to make the red agent collide each other. So you need to enable the block same type collide. So when we enable this, we need to deplace our agent and place that again and run the simulation. You can see that it will not check collide for the same type of agent, just like this. And the final thing we're going to talk about is self-collide. Let's first open this and disable that and run the simulation. You can see that the agent will penetrate the arm to the body when simulate. You can see that the arm is penetrate onto the body. Here is very obviously. This is okay if your shot is very far from the camera, for example, like this. But it's in a very close shot. This result is very unrealistic. So we need to enable the self-collide dynamic. But this kind of the features can increase the speed of the simulation. Here, let's just enable the self-collide. This will decrease the simulation speed, but the more accurate. You can see that this leg is penetrated on the left and the right leg, they penetrate each other. So let's just deplace and place our agents again and run the simulation. You can see that at this time the simulation should be the more accurate. The different bodies cannot be collide each other. It cannot be penetrate each other. You can see that the leg, the arm. So this is the more accurate. This is a relatively slower for simulation, but more accurate for the close shot. So you can control that by your real conditions. Okay, this is some of the extra features of the Physics Global. Thank you for watching. See you next time.